Welcome back. Today we will discuss about the stepper motor and servo motor. So first we will start with the stepper motor. So this stepper motor, it is a type of the electromechanical device that converts the electrical power to the mechanical power. And here also we are not using any brushes, so it is known as the brushless synchronous electric motor, and it rotates stepwise. So as the name suggests stepper, it is clear that this motor will rotate stepwise steps, so its other name is stepper motor. And here we are using the controller circuits to operate the stepper motor. When the number of pulses that are fed to the controller, then the controller circuit, it will determine the angular rotation of the motor. So first we will see the construction of the stepper motor. Okay, so same like previous motors, we are having this outer frame, this green color part, this outer frame or yoke. This part is there to protect the internal main parts from the mechanical damage. Okay, it acts as a protecting shield. Next we have the stator, this gray color part. Okay, so this stator, it is made up of the laminated silicon steel. Okay, and already many times we have discussed why we are using this laminated silicon steel, because this material is having high permeability. Okay, high permeability means the magnetic material, it is allowing large number of magnetic field to pass through it very easily. And this lamination, what is this? This lamination is the arrangement of the thin sheets of the silicon steel, and by combining them we are making this laminated silicon steel, and each silicon steel, they are having a diameter of 0.33 millimeter. Okay, now why this lamination is used? This lamination is used to reduce the electrical losses in the machines, like hysteresis loss, eddy current loss. When your magnetic material is repeatedly getting magnetized or demagnetized, then the electrical energy loss as heat, that will be less if the hysteresis loss is less. So that is why we are using this laminated silicon steel. Next we have the poles present in the stator. So these gray color, these are the field poles. Okay, now why we have these horseshoe shaped poles? So that uniform magnetic flux is maintained between the air gap of the stator and the rotor. Okay, now the poles, they are present in the inner part of the stator core, and this stator core, on these poles we have the stator winding, this brown color portion. Okay, these are called stator winding. This stator winding, it is made up of the copper. Okay, now each stator phase, they are energized separately by using the separate switches, as you can see in the connection diagram. You can see in the stator winding, which is made up of the copper, we are connecting the 4 switches, switch B, switch C and switch D. Okay, now we are using as a rotor, permanent magnet rotor we are using, due to the absence of the brushes and the commutator, just like the BLDC motor. Okay, so already constant field poles are getting generated. So usually as a permanent magnet we are using the ferromagnetic material that are getting attracted to the magnet very easily, like iron, nickel, cobalt, etc., and they can provide the required torque also. Okay, next we will see how this stepper motor works. Okay, so these red color portions, they are what? They are the windings of the stator, and we are using the copper here. Okay, so we are giving a DC supply or battery, and this DC supply or battery is connected to each field winding through different switches. Okay, now starting from switch A. Okay, at first let's say we are giving the DC supply to this A coil, and at that time switch A is on. Switch on means switch closed, and all other switches B, D, C, they are off. That means switch open. Okay. Now, since we are giving this DC supply, what will happen? This DC nature of this current, the constant magnetic field will get produced on this, on the coil A. Okay. Now, when the coil A, when this field winding it gets the DC supply, it is getting energized. Okay, now it will behave as an electromagnet. What happens in the electromagnet? The pole where the magnetic field lines they emerge, they are called north pole, and the pole where the magnetic field lines they enter, it is called the south pole. So when this field winding is getting energized by this DC supply, what will happen? this this part we have the south pole, and this part we have the north pole. Okay, now when so south pole and north pole are getting created here. Okay, now that means after energized, we have the south pole here, we have the north pole here. Now let's say for a particular position of the rotor it is made up of the permanent magnet. Now for a, when this rotor is positioned like this for a particular instant, the stator, the south pole of the stator, it will attract the north pole of the rotor. Okay, so what will happen? This rotor, it will get aligned towards the stator field winding. Okay, so that means this rotor, it will fully getting aligned towards the this pole field winding, because this north pole and this south pole they are getting attracted. Okay, next what you do? Next you make this switch B on. That means switch B will be closed and rest of the switch A, D, C, they are open. Okay, so this switch B is on means you are giving the DC supply to this field winding, and this field winding is getting energized. So here we are having south pole, here we are having the north pole. So rotor, this permanent magnet rotor is rotating. So what will happen? This south pole of the stator, it will attract the north pole of the rotor, and this rotor, it will get aligned like this towards this south pole of the rotor. Next you make this switch C, this orange color switch, this switch C on. That means this switch C will be closed and rest of the other switches will be open. So when the switch C is closed, that means these field winding will get energized. Here we have the south pole, here we have the north pole, and the rotor, it will get attracted and aligned like this. Okay, towards this particular pole of the stator. Next what you will do? Next you make only the switch D on. That means switch D will be closed and rest of other switches let it be open. So this switch, this field winding, this is getting the DC supply, right? So this field winding is getting energized and it will attract the north pole of the rotor, and this rotor will get aligned like this towards the south pole of the stator. So this is how the rotor, each time it will get attracted to each field winding of the stator. Now if let's say when this when the coil A and B, when let's say both coil A and B, when they are energized together, then both the south poles of the stator, they will attract the north pole of the rotor. Okay, and in this case the rotor will somehow get positioned at the middle between these two south pole of the stator, and we can see here the rotor is almost positioned at the 45-degree angle. So if I, in this case, if the rotor needs to complete one complete revolution in 8 step, we need to energize the two phases together like this. Okay, that means when the two phases are energized together, the rotor is getting attracted at 45-degree angle between the two phases, and in this condition this rotor or this permanent magnet will take one revolution, and this permanent magnet, it will complete one revolution in 8 step. Okay, next there is another term called the step angle. So what is the step angle? The step angle is the basic movement of the stepper motor that depends upon the number of poles in the stepper motor, and it is defined as ns minus nr divided by ns multiplied by nr into 360. What is ns? Ns is the number of stator poles and nr is the number of rotor poles. So suppose if we have a stepper motor where the number of stator pole is 4 and the number of rotor pole is 2, then if we put these values in this formula, we will get the 90 degree. Here the step angle is 90 degree. This is how we calculate the step angle in the stepper motor. Next topic is servo motor. So servo motor, it acts as the rotary actuator and it converts the electrical signal to the mechanical acceleration. Now we will understand each of these terms. What is servo motor? It is a device and it is used to precisely control the position, speed and torque of a rotating part. Okay. What is the rotary actuator? We have just here we have seen, no, the servo motor, it acts as a rotary actuator. Rotary actuator means it is a component that produces the rotational movement, nothing else. Okay, that means rotational movement means it will produce a turning motion. Next, this servo motor, it converts the electrical signal to the mechanical acceleration. That means we need to give the electrical inputs here like some control signal, and then it will convert that control signal to a physical rotational movement, like and it will cause the motor to accelerate or change the speed. And in this servo motor, we are using the position feedback system that controls the position and speed of the rotor. That we will see when we are observing this block diagram of the servo motor. So in this slide, block diagram of the servo motor is given. So if you particularly notice this block diagram, here we have the control signal. What does this control signal do? This control signal is a user input signal. Okay, so this control signal will tell the system that what position or speed needs to be reached. Okay, next we have this pulse width to voltage converter. So this control signal, it can be a pulse width signal. That means a continuously on off signal, 0 1 0 1 digital signal. This control signal either can be analog or digital. Okay, so this pulse width to voltage converter will convert that control signal into the voltage level. Suppose when we have the 0, then it may convert to 0 volt. When we have the 1, it may convert to 5 volt, like that. Okay, so that the system can understand. Now this voltage signal is given to the comparator. So this comparator, what it will do, it will compare this converted voltage or which is my desired position with the feedback signal coming from the system to see whether they are matching or not. Okay, next this comparator signal, it is given to the error amplifier. This error amplifier, it will amplify the difference between the desired position and the feedback signal that is coming, okay, to generate a correction signal. Okay, then the amplifier output, the or amplified output signal, which we are calling a variable output, this signal will indicate how much the motor should move to reach the target. Okay, then we have the motor. So this signal is given to the motor, and this motor will convert this control signal into actual mechanical movement or rotation. So actual rotation is taking place here depending upon the control signal it is receiving. Okay, so what are the next part after the motor? We have the load. So this load is that part of the system that the motor is moving or the controlling, and in this load place we can have a robotic arm or wheel. Okay, so then we have this gearbox. This gearbox, it either reduces or increases the rotation speed of the motor, and also it can reduce or increase the torque to match the loads requirement. Okay, then we have the position sensor. This position sensor, it measures the current position of the load and it gives that feedback to the system. Okay, then we have this feedback to comparator. So this position sensors signal is fed back to the comparator with the control input to determine if the motor has reached to the desired position or not. So this servo motor is mainly used in computer and robotics, whereas the stepper motor, it is used in printing and textile systems.